Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
The biological effectiveness factor is important for standardizing the different types of radiation that one can be exposed to and putting into context, what health effects and negative effects that exposure to these types of radiation can have on a living organism. Because as you can imagine, not all types of nuclear radiation are damaging in the same ways. For example, if we compare a gamma ray, there's much more likelihood that the energy can be dispersed. So what this means is if someone is exposed to a gamma ray, there's going to be the initial point on the body where the gamma ray comes in, but ultimately the energy can slowly be absorbed throughout the body, ultimately resulting in a lower likelihood that there's going to be some overarching negative effect from that. If we contrast that to an alpha particle, generally the energy from an alpha particle will be used quickly. What that means is that the alpha particle is a little bit more like a sledgehammer. It goes in, its energy immediately gets dispersed, and it causes immediate damage to the tissues nearby. And what the biological effectiveness factor takes into account are these differences between these types of radiation. And for that reason, we could predict that alpha particles will have the highest biological effectiveness factor because it can do the most damage with the same relative amount of radiation.